Hello, you are welcome to Operation 4.0 GPA online tutorials. Don't forget to subscribe, watch, share the link, and leave a comment for us to give you more. Today, we want to look at how you can find determinants of a 3 by 3 matrix. In my previous video, I showed you how you can attach signs to a particular element in a matrix. And I told you that if the subscript of that particular element, when you add them and it's even, then it is positive attached to it, and if it is odd, then it's negative. So in this case, we have 1 1, so the subscript is 1 1, so we have positive, we have 1 2, so negative, we have 1 3, so it's positive, then negative positive negative positive negative positive. So when you do it and do it, or you see that the rest of them will give you the signs that we have attached to it. So how do you find determinant of a 3 by 3 matrix? The first thing you need to ensure is that it is a square matrix, as I earlier said. So in this case, it is 3 by 3, number of rows equal to a number of columns. So it is possible to find its determinant. So the needful thing to do is to select a particular row or column that you want to use in your calculation. So for simplicity, I want to select first row, which the elements are 6 1 and 1. Don't forget that you can select any row or column at all. So what I need to do is that I'll pick the element on the row that I've selected one by one, delete their rows and columns, and then I'll just multiply it by the 2 by 2 matrix that will be left if I delete the rows and the column of that particular element. I'm going to show you how you do that. So now, my first element on this particular row that I've selected is 6. So what I need to do is that I'm going to find determinant of the 2 by 2 matrix that is left if I delete the row and column. So this one is found on the first row and the first column. So I'm going to delete that. When I delete the first row and the first column, what I'll be left with is minus 2, 5, 8, and 7. So I'm going to write minus 2, 5, 8, and 7. So I'm done with the first part. And then when I come to the second one, its sign is negative. Its sign is negative. Remember, this is plus. So for plus, we don't write it. So I'm going to clean this. So now, it's negative. So negative 1, I'm going to delete its column and row. And then the 2 by 2 that is left, I'll find its determinant. So I'm going to have, so when I delete the column and the row here, I'll be left with 4, 5, 2, and 7. Okay. And then the last one is having plus, so plus 1. I'm going to delete the row and column. So I'll delete the row and column. I'll be left with 4 minus 2, 2, 8. So after doing this, the only thing I need to do is to find a determinant of this 2 by 2 matrix and use it to multiply the element that, or the scalars that are in front of it. So now I have 6. Now this 2 by 2 matrix, you multiply what is on the main diagonal, and then you subtract what is the multiplication of what is off the main diagonal from it. So now I have minus 2 times 7 minus 8 times 5. Then minus 1, I have 4 times 7 minus 2 times 5. Then plus 1, I have 4 times 8 minus 2 times minus 2. Okay, so after doing this, what you need to do now is to do your arithmetic. So I have 6, okay, multiplied by minus 2 times 7 is minus 14, and then 8 times 5 is 40. So I have minus 40, then minus 1 multiplied by 4 times 7 is 28, then 2 times 5 is, so it's still minus 10, Then I have plus 1 multiplied by 4 times 8 is 32. Then 2 times minus 2 is minus 4, but because of the negative sign here, it becomes what? Plus. So now 6, when you do this arithmetic, you are going to get minus 54, then minus 1 multiplied by 18, then plus 1 multiplied by 36. So 6 times minus 54 will give you minus 324, then minus 1 times 18 is minus 18 plus 36. When you do this one, then our determinant of matrix A, which we have earlier said, is minus 306. So basically, that is how you find determinant of a 3 by 3 matrix. Don't forget to watch this video, share the link with your friends, let them subscribe, leave a comment for us to give you more. See you in the next video.